Okay, this video is actually on further example on alpha and beta. Okay, from here you can see how they actually change the questions. The roots that is given in this equation is no longer alpha and beta. They are given to you as alpha square and beta square. This means that the sum of roots in this question will be alpha square plus beta square instead of alpha plus beta, which is equals to minus b over a, which will be minus 1 over 4, which gives you 1/4. Okay, so the product of roots in this situation will be alpha square beta square, which is equals to 36 over 4. You can see a, b, c from here. So 36 over 4 will give you 9. And this will actually answer my question in part A. Now, let's proceed to finding the quadratic equation in part B. So, to find a quadratic equation, we need to find the sum of roots. So, the sum of roots is alpha plus beta. Given these two equations, how are we going to find alpha plus beta? Okay, if you have familiarized yourself with this type of question, you will know that there is a relationship between these few equations, that is alpha plus beta square is actually alpha square plus 2 alpha beta plus beta square. So, we can find alpha plus beta square from here. Alpha square plus beta square is 1 over 4. 2 alpha beta, we do not have alpha beta, but we can deduce that alpha beta is actually plus minus 3. So we end up having two solutions here. So this will either give me 25 over 4 or negative 23 over 4. Notice that if we can't square root a negative number, therefore we need to reject this solution. Okay, if we reject this solution, this means that alpha beta is actually equals to 3, as we have to reject the negative answer. So alpha beta is equals to 3. So back to here, alpha plus beta will give you square root of 25 over 4, which will in turn give you 5 over 2. Okay, now let's proceed to find the product of roots. So the product of roots will be alpha beta. Alpha beta, as you can see earlier, that we already know that is equals to 3. Therefore, the equation required will be x squared minus sum of roots plus product of roots. This end up having two distinct equations. So x squared minus 5 over 2x plus 3 equals 0, or x squared plus 5 over 2x plus 3 equals 0. Multiplying everything by 2, we will have 2x squared minus 5x plus 6 equals to 0. And we will have 2x squared plus 5x plus 6 equals to 0. So this will in turn solve the question in part B. Now, let's look at some further example on example 6. Example 6 will, in this question, instead of giving you one equation, you are given two different equations. Notice that the roots of these two equations are actually different. So from the first equation, we can actually deduce that alpha plus beta is actually minus p over 2. And alpha beta equals to minus half. Now, look at the second equations. The second equation, the roots will be 1 over alpha square and 1 over beta square. Therefore, the sum of roots in this situation will be 1 over alpha square plus 1 over beta square, which will in turn give you minus b, which will be 5 over 1a, which is 1, which gives you 5. Okay, and the product of roots will be 1 over alpha square times 1 over beta square, which in turn gives us q. Okay, looking at these four equations, we can actually find a value of q with these four equations. So, starting from here, we know that q is equals to 1 over alpha beta square. And 1 over alpha beta square is actually 1 over half square, which will give you negative half square, which will give you 4. Now, in order to find p, we need to make use of this equation. This equation, what we can do to them is we try to combine them together. We end up having alpha square plus beta square over alpha square beta square equals to 5. Now, looking at this equation here, we are required to find alpha square plus beta square. If you look at the previous example, you will know how to find alpha square plus beta square from these two equations. So alpha square plus beta square is equals to alpha plus beta square minus 2 alpha beta. So alpha plus beta will be minus p over 2 square minus 2 minus half. Simplifying this, we get p square over 4 plus 1. Okay, now that we have find alpha square plus beta square, we will substitute it inside this equation. P square plus 1 over 4 divided by alpha square beta square will be alpha plus beta square. So to write it a bit clearer, we will get this equation here. Okay, this may look as a complicated equation to solve, but actually there's only one unknown in this equation, so this makes this be able to solve. In order to simplify a 4-layer fraction, the trick is to multiply the top and bottom by the denominator. So simplify this a bit further for people who can't see. We'll get this. And to simplify this, we simply multiply by the denominator of the fraction here and here, which multiply here by 4 and multiply here by 4. This end up having p square plus 1 equals to 5. So p square is equals to 4. P equals to plus minus 2. Therefore, p equals to plus minus 2, q equals to 4. And this will solve the question in example 6. Okay, let's look at some more examples. Example 7. On example 7 is another way of asking. Instead of giving you two equations or changing the roots, I now insert some unknowns inside the equations. But you can see from here that the a, b, and c now will be in terms of k. So since the roots are alpha and beta, alpha plus beta will be equals to minus 2k over 3, which give you 2k over 3. And alpha beta will be k minus 1 over 3. Okay, we are given this equation, alpha square plus beta square equals to 10 over 9. So we will start playing with this, as this look a bit new to compare to other questions. So alpha square plus beta square equals to 10 over 9. What we can do is we can change this to alpha plus beta square minus 2 alpha beta equals to 10 over 9. So alpha plus beta, we have it here. It will be 2k over 3 square minus 2. Alpha beta will be k minus 1 over 3 equals to 10 over 9. Simplifying this, we get 4k square over 9 minus 2k minus 1 divided by 3 equals to 10 over 9. Multiplying everything by 9, we end up having 4k square minus 6k minus 1 equals to 10. So 4k square minus 6k plus 6 equals 10. 4k square minus 6k minus 4 equals 0. So 2k square minus 3k minus 2 equals 0. By factorizing this, we should be able to solve the equation. So by factorizing this, we have 2k plus 1 k minus 2 is equal to 0. This means that k equals to minus half or 2. So this will solve my questions in example 7. That's the reason why they ask for possible values of k. Now, Let's take a look at example 8, which is the final example that we are going to talk about. So the equation given here will be in terms of k, and they tell you that the roots are actually reciprocal of each other. So instead of giving you two equations, changing the roots, what this question is trying to tell you is that if let one of the roots be alpha, so this means that the other roots will be 1 over alpha. So applying what we know, the sum of roots will be alpha plus 1 over alpha, and this would give me minus b over a. So the b may be a bit hard to see here, but if you take note that your b is the coefficient of x, your b is actually minus k squared minus 1. So, and this will be your a, and this will be your c. So the sum of roots is actually minus b minus b squared minus k squared minus 1 over k. Simplifying this, we end up having k squared plus 1 over k. So this will be complicated now. So let's proceed to find the other one. So alpha times 1 over alpha, which is the product of roots, is actually equals to 6 minus k. Okay, this will be hard to solve, but looking at this equation, it seems easy. We can actually cancel out my alpha, so 1 equals to 6 minus k. Therefore, k is equals to 5. Notice that the question only asks for the value of k. Therefore, here will give us the value of k. This means that this equation is actually redundant. However, if we are asked to solve for the roots, what we can actually do is just substitute this value of 5 back here. So alpha plus 1 over alpha equals to 5 squared plus 1 over 5. This will give us alpha plus 1 over alpha equals to 26 over 5. Multiplying everything by alpha, we will end up having alpha squared plus 1 equals to 26 over 5 alpha. Multiply everything by 5, we have 5 alpha squared plus 1 equals to 26 alpha. So this means that 5 alpha squared minus 26 alpha plus 1 equals to 0. And solving this equation will help us find alpha. But do note that the alpha, if you attempt to solve this equation, is actually unfactorizable. It's actually unsolvable because your alpha will be equals to 26 plus minus square root 26 squared minus 4 AC. You will notice that you will need to square a negative number here, and this result that x is actually a complex, alpha is actually a complex root. But in question where they ask you to find for k and alpha, this equation will end up solvable. Okay, that's it. Thank you.